everyone. Today we'll be discussing about the analog and digital data transmission, how the data is being transferred from one end to another end. That you will be learning in this today's session. So in this today's session, we will be having the concept of how the data is being transmitted. So entities convey, okay, whichever entities which are there within the transmission medium, those are said to be conveying certain meaning from one end to another end. Okay, those are said to be the data. Conveying meaning is nothing but, okay, when I am said to be sending the data, it has to have certain meaning when the data is being transferred. Okay, I send a video, it has a meaning. Okay, I send a message, it will be certainly having certain meaning. That is said to be a data. And signal and signaling is nothing but the signals which are generated, it is through a which of the formats which are there. So each and everywhere you need a electromagnetic representation in the format of zeros and ones. It will be represented. That electricity flow is said to be represented in zeros and ones, and whichever medium is there, whichever medium you are using, it should be helpful for transmitting the data from one end to another end. And in the transmission part, the communication of the data is by propagation and processing of signals. Propagation is nothing but at each and every level when the data is being communicated, it should propagate to each other. It should be having the communication between each other, and it should be processing the signal so that the other signal it doesn't get disturbed. Okay, that is said to be the transmission part. So audio signals, when you are considering any of the signaling parts that are transmitted, it has the types. It may be audio or a video signal, whichever types of signals are there. In this signals, it has a range. So a frequency, yesterday as we learned, it's nothing but when the waveform starts and ends, it will be having a frequency at which it will be moving. 1 second, okay, this much hertz of data is being transmitted. So that is said to be the frequency. So in the audio signals, you have a frequency of about 20 hertz to 20k hertz, whereas easily converted into a electromagnetic signal. Electromagnetic signals are nothing but when the data is being transmitted, the electricity is being generated when the data is transmitted. So how these concurrently move from one end to another end, that is said to be your electromagnetic signals. And varying volume is said to be converted to varying voltage. Whichever volume which is generated by us, it will be converted back to voltages which are being transferred. Okay, can limit frequency range for voice channel to 300 to 3400 hertz. Only the data which is said to be transmitted from one end to another end is about this range. Okay, 300 to 3400 hertz. It can transmit the data from one end to another end. Okay, this is the part of your audio signals. When it is said to be a digital data, you all know the digital data, whatever you are set to be processing in any of the devices, it may be a computer, it may be a mobile, all those are said to be generating the binary signals, nothing of ones and zeros. So it is between the two components which are said to be having the direct current which get links from one device to another device. Okay, and the bandwidth, it depends upon the data rate. Mainly whatever bandwidth of data is being generated, so this is your bandwidth. So it depends on whichever data you are said to be transmitting. So when you are transmitting the data, it depends on your mainly the bandwidth which is being generated from one end to another end, how much the bandwidth is said to be present. Okay, and analog signals, this is an example about the analog signals, how they are said to be generated, analog and digital. So they are said to be continuous. Okay, the data is being transmitted, it will be continuous from one end to another end, in between whichever device is there, though it is there, it will be converting back. So nowadays you are said to be using the like a digital concept where the data is being transmitted in digitalized way. So data, when it is being transmitted in the, it will be in the format of like this way, binaries, ones and zeros. When it reaches its modem it transfers back the data into a particular analog signal. You get a data in digital format and then convert it into a analog signal. Digital signal, how it is said to be represented is, okay, when a data is being transmitted in the beginning, you are said to be transmitting the analog signal, and a code decoder it will be there. It decodes back into its specific digital format. So when you are using the digital devices only, what happens is you get the digital device information. A digital transceiver is there that it will convert back into a digital format only. Mobile to mobile. So it's a digital devices. So that use the digital transceivers. Okay, when it is not a mobile to mobile or any of the digital to digital devices, it is said to be a analog to digital signal. Okay. So the advantages over the digital signals is nothing but digital signals are said to be cheaper mainly and less susceptible to noise. It cannot accept much noise. Okay, but greater attenuation is nothing but it has more disturbances. Loss of energy will be there. Each and every time you need a device which will make your signals strengthen. Nothing but your repeaters or the regenerators are needed to make your signal stronger. And digital now preferred choice, but mainly nowadays the choice is between a digital devices only. Okay, that are the advantages. And transmission impairments. While the data is being transmitted, there is a chances of your data to degrade your signal quality. Okay, mainly in the analog devices, it degrades the signals, but it gives the signal, but it degrades the signal. Whereas in the digital devices, it has the errors mainly. Okay, which is like difficult to manage when it is concerned to your digital devices. And mainly the physical impairments are of three types. One is said to be attenuation, then you have the distortion and the noise. So what do you mean by attenuation? Is attenuation is nothing but it will be like when the data is being transmitted, automatically the strength of the signal becomes less, means the strength of it falls. And it depends upon even the medium also where you are said to be transmitting, whichever wire medium or wireless medium you are using. Wireless means attenuation will be more because each and every time it will be going through the air, so signal it degrades. Okay. And received signal strength, it's strong enough to detect by that particular device which is there. And significant higher noise is there. When high noise is there means what? Error will be there. When you consider a Wi-Fi, when you consider a wireless mediums, it will be having the highest errors. So in order to make those signals to get to a higher rate or lessen the errors, you need an amplifier or a repeater. And increasing these devices which will help you out in increasing the frequency of the data. And each and every time it makes the frequencies at an equal level to flow from one end to another end. Okay, that is attenuation. And delayed distortion. Distortion is nothing but the variation in the frequencies, that is said to be your distortion. Okay, hence frequency components arrive at different times. At each and every level you have an amplifier, amplifier, amplifier. At each and every like 1,000 kilometers or something, you have an amplifier which makes your data to have a normal frequency. To in order to have a normal frequency, these devices are very important in between. So your delays, distortion, it will be reduced. Otherwise, it will be having more distortion each and every time. The frequency may vary. Okay, and it is particularly critical for the digital data that your waveforms remains the same when the data is transmitted, and it's a part of your when if the data amplifiers are not said to be present means your data it will be split over. Okay, your digital format it may get disturbed at each and every level. So it is necessary to avoid the delay distortion that it is being done through the various devices, amplifiers or the repeaters. Okay, causing interference. And this delay distortion is nothing but each and every time when I receive the data at the other end, it will be delayed mainly. Your data it received at a late phase. Okay, so it is also a impairment in the transmission. And noise is one of the thing which is the most important one when the data is being transmitted. Unwanted signals which are generated. through any of the transmitter or the receiver are said to be your noise. Mainly those are said to be the thermal agitations. Thermal agitations is nothing but the heat which is being generated by the various devices. That is the most important aspect. When it generates more heat, more noise will be there, more chances of disturbing of the things of data it is there. So uniformly it is said to be distributed. When your data is like this, it gets disturbed at each and every level. That is uniformly here also it gets disturbed. So how the noise is being calculated is, that is N naught is equal to KT. N naught is nothing but your noise, and K is nothing but your constant value 1.38 into 10 to the power of minus 23, and T is your temperature. Mainly in the environment the interferences are said to be more. When multiple uses, more noise will be generated. In the mobile environment, the even a single small difference in the heat generation, it generates to more errors and more disturbances in the signal. Okay, that is said to be your noise. In the noise is also said to be having your crosstalk. If you have a line or a signal which is said to be connected to multiple other signals, then it is said to be a crosstalk, which may leads to noise. Okay, when a noise is there, automatically the signal may change to something else. You have called somebody and it reaches to somebody else. And even it generates the impulses. Irregular pulses are being generated in the impulse concept. Irregular signals is nothing but the signals which are not common. Those are said to be impulses which are said to be irregular. It is said to be short for short duration, but higher amplitudes it will be there. And minor it may get corrected, but major ones, the errors it will be generated in the noise. Okay. Noise, these are the examples how the noise are being generated. You can check out the disturbances regularly, which happens between ones and zeros in the signal. Next one is your data rate. Data rate is nothing but in 1 second how many bits travel from one end to another. So example, if this is your 1 second, in this 1 second how many signals are being generated, those are said to be your data rate. How it is calculated is, you can check out here, 1 by bit duration. 1 by bit duration, 1 divided by the time taken for each bit to travel. It's nothing but that is said to be your data rate, which is being calculated. And even bit rate is also common, like how many bits travel in 1 second, that is said to be your bit rate. And bit length, how many bits are travel from one end to another end in 1 second. Okay. And last part you will be learning about the spectrum or the bandwidth and data rate. Spectrum is nothing but the range of frequencies which are there. Okay, you are said to be having multiple ranges of frequencies down and up, and you have in between other signals also. That is said to be your spectrum of signal. It will be having two types, absolute bandwidth and the effective bandwidth. The width of the spectrum, when it is said to be normal, when it is said to be a proper one, and it is said to be absolute, is nothing but okay, this much. Okay, this is your bandwidth, this is your absolute one. Effective one is nothing but you have multiple relative bands which are being generated at a time. That is said to be your effective bandwidth. And the transmission of the data, it is which is said to be related to the bandwidth, it is said to be limited to from one system to another system. It has a limit. Okay, this much bandwidth it can cover from one end to another end. And the bandwidth which are there, the signals which are generated in the square wave format, they have more energy than the analog signals. And even a limited bandwidth is nothing but it can be occupied through the distortion. The delay which happens when the data is transmitted, it is because of the limited bandwidth which is there. Okay. And data rate also, it carries a less data rate when you consider a bigger frequency. And bandwidth, this is how a bandwidth would be there. You can see the example how it is being present here over the network. In the network you have the bandwidths like this. From here to here you have a normal bandwidth which is being covered from one end to another end. Okay, how it is being calculated as 3f minus 1f. It's nothing but if it is 3f here minus the 1f. 3 minus 1, how much bandwidth is being covered between two consecutive signals. That is said to be your bandwidth. Okay, absolute it's nothing but the infinity signal, and effective is 1 by x. These are the various bandwidth signals which are being generated. You can check out. You have multiple bandwidth at different hertz which are there. Higher hertz you have the disturbance. When you have normal hertz you have normal ones. Okay. And last one, the channel capacity. Channel capacity is nothing but how much data it can be transmitted over a given communication path. Okay, this is your transmission path in which how much capacity of data can be sent over this particular line. Nothing but any of the cables or the Wi-Fi mediums or the whichever wireless mediums. How much capacity of bandwidth it can handle. That is said to be your channel capacity. The channel capacity, it depends on the data rate, which kind of data you are sending, and what is the data rate that is said to be concerned here, how much data is being transmitted and how much bandwidth it covers and how much noise it can be able to handle, and what are the error rates which are there. So when the data is sent, all these are said to be calculated, then only the data is being sent over the transmission medium. So these are the concepts which you have learned today.